All right, now that we have an overview of how the program runs, and obviously you're not going to have a running program to look at before you design it, but you will have an idea in your mind of what things will look like or should look like as the program runs. And I just thought that showing you how the program actually behaved will make it more educational as you see the design effort that goes into the project itself. So now what we want to talk about is what are the objects, the non-standard objects, that we have to contend with. In other words, what objects am I going to have to work with that aren't pre-canned and are not part of the 4,000 cookie cutters already hanging on the wall? Well, the games classes then that we have to consider, the first one is that we have to have a class that's going to abide by the rules. In other words, something that's going to monitor to make sure the player isn't bending or breaking the rules of the game. So we'll have a rules class of some kind. We just don't exactly know what it is right now. The second one is we're going to write a card deck class. And I'm probably going to spend a little more time on the card deck class because I know that I might want to write another game of some kind down the road, and I want to make this class extensible in the sense that I might be able to use it in some other games at some later date. So I'll give a little more thought to that as I write it. Well, with that in mind then, the next step is we've gone through the 5 programming steps. We thought through the user interface, and that's really where the 5 programming steps are most useful. What we want to do now is to use UML to give our thought process a little more concrete feel to it as far as the design goes. So what I have here are what I envision at this point in time a rules class. And the rules, I'm going to create properties for those things right now that I feel are going to be important in terms of the rules of playing the game. And I'm going to devise the methods that I think I need to have to enforce those rules. And we're going to use the UML Lite that we talked about earlier in this course as the starting point. Now, I ran out of real estate. We've only got so many Pico acres on this screen, so I ran out of real estate, and I bent the methods down at the bottom to spill over to the right a little bit, but you'll get the idea. So I've named this class in between rules, and the first thing that I have is balance. And if you'll recall, a negative sign in front of balance means that this is going to have the private access specifier associated with it. And you should know by now that we do that to enforce part of that trilogy of object-oriented programming, encapsulation. So we're going to hide balance, bury it inside of the class, and we're going to have balance be an int. Now that seems a little strange to have money stated as an integer, but I am going to have the rules be that you can only bet dollar amounts. You can't do $10.50 or something like that. So it's okay for us to handle the dollars as integers, and that's what we're going to do. Wager, the same basic philosophy. We make it private because we don't want to have the outside world have direct access to that amount. And it also is an int. All of them, obviously, except for the last property, are going to be integer variables. The low card we're going to have to keep track of because that sets the lower limit to what the bet range is going to be. That was what you saw on the left text box. The low card index is what index position does this card have into the deck of cards. That becomes important because I've given some thought to how I want to write the card deck. So I need a card index to tell me where I am in the stack of cards. The high card is sort of the mirror image of the low card. It represents the upper limit of the betting range and tells me where a tie or higher would represent a lose, whereas the low card, a tie or lower than that, represents a lose. Therefore, anything between those two extremes would represent a win. So I also need to have a high card index to go with the high card. So those two pair together, low card index, high card index. The dealt card is the third card that appears after the person decides whether or not to bet. So that's the card that will appear either between those two extremes, above it, or below it. And we also need to have a dealt card index, and it too is private. All of these are private, which is the way you should do all of your property methods anyway. The last part of the rules is a variable called myDeck. In other words, this is going to be my deck of cards. This is the deck of cards that I'm going to be working through when I use the card deck class. I'm going to create an object of class card deck, and I'm going to maintain it in my rules class. So this is a very common process where you have a class buried within a class. Nothing unusual about it. You'll see it all the time. If you remember, then the top box is the name of the object that we're working with. The second box are the properties that we're going to be working with. And the bottom box, in this case, the bottom two boxes, are the methods that we want to put in this particular object. You'll notice that we don't have the property methods listed. That's a standard UML technique because you assume that if there's a balance, a wager, whatever, and they have the private access specifier, the only way to change those would be through a property method. So obviously when you see a minus sign in front of any property, there must be a corresponding property method associated with it, or you'd never be able to change it. So by inference, all of the private methods will have to have an associated property method. And there's no sense complicating the diagram with those. Okay, that being said, then we can go down and look at the methods that form the interface to this class. And because they form the interface, you'll notice we have plus signs in front of all of them. And that, if you'll remember, is sort of an abbreviation for the word public. So all of these general methods, and you'll recall a general method has to have a public access specifier. All of these form the way that someone in the outside world is going to interact with our rules class. Okay, the first rule is we have to deal a card, so we get the first card. We get the second card, which we don't know at this point whether they're high or low. There's no guarantee. And we have to get a dealt card. Once we do that, there has to be a mechanism that is going to decide the low card versus the high card. So we have to have not really a sort routine, but a compare routine that's going to decide which one's going to be displayed in the low box, which one's going to be displayed in the upper box. Then we have to be able to call a shuffle routine. And I've written this as a separate routine because there may be some games that use more than one deck, canasta, for example. So if I were writing rules for canasta, shuffle is entirely different than what the card deck shuffle would represent. So if I were playing canasta, I would have to call shuffle twice to play with a larger deck of cards. The other thing that I want to do is I want to be able to check before or after, depending on how I feel about it, how many cards are left in the deck. Because if there's fewer than 3, then I really should reshuffle the deck. So I'm going to keep track of the number of cards that I have available to me as I play the game. The method on the top of the right-hand box called deal hand is what I'm going to actually visually represent on the screen. And I'm going to have the hand as a string. I'm going to have the outcome as an integer variable, but I'm going to pass it in as a reference variable. What that means is I'm not passing in the R value. I'm passing in the L value. And the reason is because whenever you pass something on the stack, if it's not a reference variable, you get a copy of that variable. But what I want to do in deal hand is I want the method deal hand to be able to directly change outcome and position. That is going to be the responsibility of deal hand. So I pass it in as a pointer variable. I pass in the L value of both of those variables. And that allows this method to permanently change those in the program. And then finally, the last thing that I want to do is to discuss bet covered. In other words, did I have enough money to pay for the bet that I'm showing in the wager window? These then, right now, at the design stage, these are the properties and the methods that I think the rules class has to have to effectively play the game. Now, this UML diagram is not etched in stone. And in fact, in real life, when I had my own software company, we would get to this stage and then we would have a meeting of more than one programmer. We might have as many as 5 come in, and we would go do a walkthrough through the design. Now, you've all probably heard of code walkthroughs, but it also is beneficial to do design walkthroughs. It's a lot easier to correct mistakes in the design stage than it is to undo code and correct them after you've already written the code. Plus, you have to throw out or modify existing code, and that's always an expensive proposition. So right now, this is our design for the rules class, and it's etched in Jello. It can morph into something different. This is my first crack at what I'm going to call the design for the card deck. The first thing is the deck size, because as I mentioned before, maybe I want to be able to handle something like a euchre deck, which is smaller than a normal deck, or maybe I want to play canasta, which takes 2 decks. So I'm going to have a variable that determines the deck size and allows me to change it if I need to. The second thing that I have is in the property list are pips. Pips refer to the visual representation of the card. There are graphic drawings for each of the cards in a deck of cards readily available. In fact, Microsoft provides those. I just didn't want to take the time to do it and look it up, to tell you the truth. So I just made my own, and it's pretty simple, and you'll see how it looks. I've made it static, and the reason is because pips is a read-only data item. And almost any time that I have a read-only data item, I'm going to make it a static. Because what that means is that this class, no matter how many objects are instantiated of this class, there's only going to be one pips array. And that makes sense. Even if I have 100 people playing this card game at the same time, we don't need more than one pip array. They can all draw from it because they're only reading it. They're not modifying it. The next property that I'm interested in is the next card, and I'm going to make that an integer variable. I'm going to have a deck, and obviously the deck is going to be determined by the deck size property that we talked about first. And that's going to be an array of integers. And in most cases, it's going to be 52 or 53, depending on how we want to start numbering the cards. And the last property is a pass count, and that tells me how many passes I've made through the deck. And that could be important on some card games. I do use it here to determine how many times we've been through the deck. Once we've got the property methods, again, those are all private. So we know that there are property methods associated with each one of those because we must be able to change those. We don't draw the property methods in just to save space, as I mentioned before. Then we come to the class methods. Again, because all of these are plus signs, we know that every one of them are public. And what that means is that each one of these are going to be part of the user interface. In other words, our programmer is going to call into these to work with the card deck. The first thing that we want to do is we want to provide the ability to shuffle the deck. The next thing that we want to do is to be able to get one card. And the integer is going to tell us which card to get, and the string returned is going to give us the pip for it. Okay? So we're going to pass in maybe an index of 23, and maybe that equates to the 3 of hearts or something. So 23 coming in comes back as a 3H as a string. Get the card pip, we can do the same thing. It's get one card. That could be an index. If I want to know a specific card in the pip array, this will allow me to get that position. So if I want to know what the 5th position is in the array, I can pass it in and it'll pass back that particular position. Get one card and get one pip really are the same thing, but their purposes are different. Get cards left in deck. When you're dealing the game, you remember one of the rules was we didn't want to deal the next hand if there weren't enough cards to have 3 cards dealt. So you can call get cards left in deck. If it's less than 3, then you need to do a shuffle. So you would call the shuffle deck routine to reshuffle the deck. Get cards left. There are some games where you want to know how many cards are left to be dealt in a particular hand. Like if you're playing Texas Hold'em, You want to know how many cards have to be dealt before this particular hand is dealt. So I put that in, and it's available for use. This then becomes the overall design for the card deck. And again, it's not etched in stone either. We will probably find, especially if we want to use this in other card games, that we're going to have to add perhaps more properties and more methods to get it to function with different types of card games. But for now, this should work and provide a basis for us to work on our project. What we want to do now is to actually go look at the code associated with this game.